Hey guys, welcome to your math helper for lesson 18, module 2. This lesson is kind of continuing on with what we were doing yesterday in lesson 17, in that we are rounding and estimating for two-digit divisors. And so what this kind of does is just kind of extends it just a little bit and gives you a little bit to think about, and then just a little more practice. So we should be on our way pretty quick with this one. So I think I have 5 problems for you. So the first problem is let's do 8,095, and we're going to divide that by 23. And what we're doing when we look at this is I also want you to take a look first at this divisor and see if you can round that to something, and round it to the nearest 10 in this case. And so 23, we're just going to round it to the nearest 10 and take that down to 20. And if I do that, I'm going to take a look at this 8,095, and I'm going to round that to something that makes my life a little easier and makes sense to divide by 20. And so 8 and 2, they're compatible. That works for me. So I'm going to keep it at 8,000. Now, when I look at this, we kind of talked a little bit about it yesterday, that you can go ahead, you can cross off these zeros. You can cross off these zeros because 8,000 divided by 20 is exactly the same as 800 divided by 2. I'm going to get the same quotient if I go ahead and do those. And I can prove that to you. 20, if I count by 20s, 20, 40, 60, 80, it's 4. If I count by 20s, and so that would be 4 to get to there, into that 80, and then I would have 400. My quotient over here, well, if I take 800 and just cut it in half, I'm also going to get 400. So, dropping off these zeros and simplifying this equation, it sure makes it easier in my mind to find that quotient. So let's continue on with that in mind. With 2,681, and we're going to divide it by 48. And we're going to do the same thing. So 48, we're going to turn that into 50. It's closest 10, round it to the nearest 10. And so then I have this 2,691. And if I think about that, it's kind of in the middle. It's not exactly in the middle. It's definitely closer to one side than the other. But could I do, I could do 2,500. And that would give me something pretty close. I could also take it up to 3,000 and also divide that by 50. And I want to kind of compare these two and see what the difference is between these two, because they're relatively close. The midway point would be 2,750, and so obviously we're a little bit lower than that. But I'm just kind of curious at this point to see what happens. So let's go ahead. Let's simplify these to get these a little bit easier. I would do 250 divided by 5, because I can drop off these two zeros. If I have a 0 here and a 0 here, I could drop it off, and it's still going to be the same thing. And here with this one, I can make this 300 divided by 5. And so 25 divided by 5 is going to be 5, and I have my 0 still. And 30 divided by 5 is going to be 6, and I have my 0 still. And so I have a 50 here and I have a 60 here, and I know that this one was closer, so in my mind I'm thinking that this 50 is definitely going to be a closer estimated quotient, or a more accurate one. But it doesn't necessarily mean that this one was wrong. And so when we're estimating these quotients, when we're rounding, you really need to just kind of keep in mind of what it is that you're doing this for and how exact you need to be. Okay, let's do another question. Problem 3. 5,484, and divide that by 71. If I go ahead and take my 71, turn that into a 70. Then I need to figure out what I want to do over here with my 5,000. I would turn that into, I'm thinking about 7, so I'm thinking about multiples of 7. I'm thinking it goes to 56. And so if I had 5,600 divided by 70, then I can simplify that down into 560 divided by 7, and 56 divided by 7, well, that's 8. And I have my 0, so I have an estimated quotient of 80. I want to take one more look at an example where we can go above or below and see the difference, and then we're kind of done here. 9,215, and let's divide this one by 95. 95 is a good example of something that's, it's pretty much smack dab in the middle, right? 95, and so traditionally you're going to round up to get to that. You're going to round up because, well, it's 95, you got to round up. But what I want to do is take a look at if we went to 90, if we went it down, we would do this one. We would round this one down to 9,000 and go for it. And if I rounded up, I would round up to 100, and I would still do 9,000 because it would be the easiest. And if I were to simplify that slightly, I would get 900 and divide that by 9, and I would get 900, and I would divide that by 10. And 9 goes into 9 one time, and I have my 2 zeros, so I would get 100. And this goes into 990 times. And so I would have two estimated quotients, one of 90 and one of 100. And those would be pretty close. Those would both be not too far off from our actual quotient. Could I keep it? Let's look at another possibility. Then. Could I keep this just straight at 95? Since 95 is maybe not such a horrible thing to deal with if I can go ahead and make this something that's close. And as I'm looking at this, I see 9. I see my 9. So instead of 9,215, can I just make that 9,500? And then when I'm looking at that, well, that seems pretty easy. I can do that. 95 goes into 95 one time, and I'm left with that. So I get an estimated quotient of 100. And looking at that, I got to think to myself, was the actual quotient, is the actual going to be higher or lower than this 100? Well, we went up when we rounded our 9,500, so I can guess that the actual quotient will be a little bit lower than this 100, somewhere in the middle. So as you're doing this, I guess the takeaway from this is to understand that, not necessarily, there's not necessarily one right answer for all of these. You can look at it multiple ways. I think as long as you're keeping it close, with something like this, well, I wouldn't go, well, I'm going to take this to 50 and take that to 5,000, and then you're really not doing yourself any favors. You want to try and keep things relatively close to the original problem, so that you can be sure that you're getting something close to the actual quotient. So, anyways, rock it out. You guys got this. We're rolling. I think everybody's feeling pretty good about it. I'm feeling good about it. Keep up the good work, and if you have questions, post them, and bring questions to class. And hasta la vista, baby.